Hello, everyone. Sorry for the delay. We're having some slight technical issues with the internet. So I'm Tiago, and he's my brother Hugo. We're both the developers of Solnet, uh, the original developers. I mean, we already have a few contributions. Um, so I guess I'm going to start by showing the page of the project and talk a bit to what led us here. Where is the screen sharing? Oh my God, I haven't used Zoom in a while. Oh, there it is. Is it working? Yeah. Okay, so in this GitHub page, the Block Mountain page, you can find all the projects that we're working on, both related and some not directly related to Solnet. Currently, we have Solnet as the main repo. We have the barely minted Solnet Anchor repo, and still not finished the Metaplex one, Ravion, and what am I missing, Google?
Well, there's also
okay, yeah, the Zero one.
Yeah, and there's also the one figure library, which is already quite old. It hasn't been touched in like 3 months or almost.
There's something still not yet public because it's still very early, but you'll soon find more about it. And it's the reason that led us to create a Solnet in the first place. So going a bit for history reasons in context, we started developing Solnet in the previous hackathon. We had another idea, but when we started delving into code and trying to develop that idea, we found out that there was no C# SDK. So basically, we changed our mind back then. We started with Solnet, and now we have the tools that allow us to actually develop that tool. This was only 4 months ago. So for anyone out there who thinks it's too late or is not sure if this is the right move to make to develop for Solana, I encourage you to actually start reading, either try to find something that you feel like it's missing, or maybe contribute to the several other, or even Solnet or the other SDKs. Because when we started Solnet 4 months ago, there were only 4 SDKs back then. It was the Java one from Skynet, and then there was a Python one, right?
Yeah, I think you had the original one in Java, which Skynet ended up porting. You had the Python one, and then there was Web3.js and obviously the Rust SDK.
Yeah, so, and this was 4 months ago. Now you have an endless stream of SDKs from Golang, there's Swift, there's a lot of other stuff that I don't recall right now, but yeah, we even made a community of SDK devs from everyone trying to expand the ecosystem. And yeah, that led us to start working on Solnet. The main goal was to cover the entire RPC API, which it is 100% covered as of now. Also, we have most of the SPL covered. I think there's like a couple missing.
Yeah, we don't yet have the stake program and the governance, which is going to be very important in the near future, with DAOs showing up and stuff like that. Obviously, it's one thing that we want to work on in the near future.
Okay, beyond directly the RPC and the programs, we also have a very nice contribution from what's his name? I'm sorry. Liquizard with the token wallets that allows a lot of flexibility and ease of use to handle the account and the associated token accounts. And we have the transaction and message API, which is very similar to the Web3.js, with also some quality of life stuff on top of it. Beyond this, we have the Zero, which is now finalized, and Mango, it's a whip, along with Metaplex and a few others. Oh, and another one very important that I've also been working in the past week, which is the Solnet.anchor. It is on a very good state right now. It's still not production ready, but I'll give a sneak peek before we end this session. As of requirements, you only need net 5. It has just a couple of dependencies. We even trimmed a few others to help decrease the load size in the Blazor WebAssembly. So this is another plus. You can use Solnet to develop WebAssembly apps, which Google can show what he's been working on. Feel free to contribute if .NET is your thing. If it's not your thing, feel free to come to this site. We have cool stuff. We have this. I would say it's still a whip because it's only focused on the Solnet core. It doesn't feature anything related to Serum or any other library that you're currently working on. We have a couple of articles here and the entire API documentation that you can find inside the code itself. Okay, we have a couple, 3 articles here. One, it's a very simple article. It's just how can you use this, what steps you need to take, and it's important to mention that it's all on Nuget, and this picture is somewhat outdated. As you can see, we have a couple more libraries there if the page loads. Okay. There is something that I need to mention, which is if you're using the Blazor WebAssembly, you can only use the async functions. The non-async will throw a platform not supported exception. And the WebSockets isn't yet 100% functional. It's something that we need to look for in the future. Okay, searching for Solnets in NuGet, we'll get a few more hits than what we saw before. Yeah, so there's the zero, it's finalized, 1.0. Great work by Hugo, and the Solnet extensions, which was mainly contributions from LeakWizard. Very a very great shout out for you. Thank you for the great work, dude. Yeah, and I think right now I'm going to pass to Hugo so he can show you how easy it is to build using Solnet, and he's going to do a walkthrough with the hello world.
Yeah, before I actually dive on to that, I just want to say something that we actually had discussed earlier that we should mention in this presentation, and I already saw someone asking the question in the chat, which is regarding the use of Solnet on Unity. As of this moment, because Solnet is targeting to .NET 5, you can't use Solnet with Unity, so you can't have like direct integration of Solana into any game, just like that. But there was one port of the first release of Solnet, if I'm not mistaken, done by the guys from All Art Protocol, and they created a Solana Unity wallet SDK, something. I think that was the name that they called it, which you could integrate to games using Unity. And for the future, this integration is going to be a lot easier because we know that there are already been done some great strides to have .NET 6 on Unity in the future, and .NET 6 is going to be released later this year, if I'm not mistaken. That's right.
Yeah, it should be November.
Yeah, just to make sure. And once that's released, I think it will be a matter of, I don't know, maybe 1-2 months before Unity actually starts to support .NET 6 as well. Since the previews have already been out for a while already, and they have already started discussing that it should happen sooner than we expect, to be honest. Okay, so now for me, I'm gonna dive into the. Just let me select the correct screen. Okay, I'm gonna dive into the hello world. I'm not sure. Is it showing up properly? Yeah, that's fine. Okay, so basically what we have here is a very simple example of what you can do using Solnet. Obviously,
Maybe let me just introduce something quickly. Just do a slight zoom in on your ID so it shows better if people are using like full HD screens.
Yeah, how am I gonna zoom in like that?
Try control scrolling or control plus or something like that. Okay.
Oh, you mean on the, yeah, okay.
Yeah. Yeah. Should probably do that in the ID too. ID, no, I mean the browser.
Yeah. Okay, so yeah, basically I have a 1440p screen, so I didn't want to mess up the aspect ratio or downsizing it. But yeah, I was gonna say, you can't write Solana programs directly with C#, but you can interact with them. We have written Solnet.serum to interact with the Serum program. We've written a couple of program implementations, which you can find in solnet.programs for the associated token account program, the system program, token program. All of these are basically fully features. You can do operations using multi-signature accounts using the token program. You can do pretty much all of these things from .NET, but you can't directly write Solana programs using .NET. In the future, once we have Solnet.Anchor released and production ready, obviously it's going to be even easier. And with some of the things that we're going to show after, you'll see why having this whole stack is actually going to be very good, not just for obviously .NET, but also for Solana as well, because this is a quite big community, still quite big community of developers that we should tap into by having these kind of tools. Okay, so I'm just gonna dive into this. I have already added the Solnet dependencies here. I'm assuming you know how to create a .NET project. In this case, I'm using Rider because of just to showcase the fact that this is actually cross-platform. I could create a new project here and just give it some name. I already went ahead though, and I already created the project and I added the dependencies. I added the RPC, the wallet, and the programs, which is the ones we're going to use in this example specifically. Okay, so in this case, obviously this is an hello world only. I'm going to remove this, and we're going to start off by creating the wallet. This wallet that I'm going to create, it's going to be how should I put it? It's a wallet basically, obviously, but it's going to feature the same keys as you would see on Solid or Phantom, for example. But we also have the functionality to create wallets and generate the same keys as in the Solana keygen command line tool. We have an open issue in the project so that we can feature more wallets, but it's something that needs to be worked on in the future so that we can actually support more stuff like Ledger and others. Okay, so I'm just gonna go. This is probably gonna lag a bit because of my PC and the stream. Here, you can see, obviously, you can choose from the different types of wallets and mnemonics. In this case, I'm going to go follow word by word the yellow world example. I'm going to create a wallet with a 24-word mnemonic in English words. I'm just going
to... Hugo, try to zoom in a bit more. People are still complaining that it's not readable.
You mean on the ID, right?
Yeah, a bit more. Okay, I think that should be better.
Okay. So I'm going to print the mnemonic here, just the mnemonic. Actually, I'll do the public key. This is the account. I'll just look at that. We have implemented some, obviously quality of life things in the wallet package specifically because of conversion between strings and public keys and private keys and stuff like that, so that you don't actually need to be accessing the properties to get the actual public key and then the actual key. So in doing things like this, it should obviously make your life easier. No, as you can see here, we have our mnemonic, we have our public key. And with this, we can actually start to do some things. I'm going to do something different for the sake of this. Which is okay. I'm going to hardcode the mnemonic here just to show you that you can actually do it like this as well. I'm going to run it again, and it should. Yeah, we have the same mnemonic, and we have the same quality. Okay, so moving forward, we're going to start using the RPC. We have our wallet, so we are going to want our RPC client, and we have implemented factory patterns on these. So what we're going to do is we're going to access our client factory, and we're going to get the client. In this case, we're going with testnet, so I can actually replicate the requesting of an airdrop, so we can get numbers, and so we can do something else with those numbers afterwards. If I'm not mistaken, yeah, this is that part. Yeah. Okay, so we have put this here. We have that now. What happens is we don't have any balance in this account or in this quality actually. So when we do a get balance on these specific accounts, we are going to see that we are going to see that I'm not even sure it shouldn't return anything, if I'm not mistaken, or it's going to return that it didn't find the account. What? Okay, I just saw someone asking, what if you have different accounts, which one will be selected? Okay. So this obviously depends. If the mnemonic you input and the way you generate the wallet is by following the Solana keygen command line keys, basically, you are only going to have one account. The default way, this account is the first account by the derivation path. So if you wanted to get your second account, you would probably do something like this. In doing this,
maybe they could be asking about if you had another key pair, and in that case you can initialize the wallet with any other valid mnemonic, or the bytes for the keys as well.
Oh yeah, obviously you can initialize accounts themselves using either the bytes that represent the private key and the public key, or the strings for the private key and the public key. This is for accounts, because basically an account is something that is able to sign something, so you can interact with the network and the cluster, basically. If you're just looking for the keys themselves, you can obviously initialize a public key using the same thing. Basically, you have a overloads for a string, for a byte array, and a read-only span of bytes, basically. Okay, so moving forward here, I'm asking for the balance of this account, because we actually implemented a completely how do you say it? I'm actually missing the word. We actually implemented a full fidelity implementation of the RPC, what you're going to have is in certain methods, you're going to have this response value. And what this response value contains is basically the context for that specific response that you're getting from the RPC. In this case, this means that the object contains the slots, which you can see here. It contains the slots. That's just the slot, right?
Yeah.
Just the slots. Basically, that.
But the idea behind this was.
Yeah, go on.
Sorry, go ahead. Okay. The idea here was to keep full fidelity from the original RPC, JSON RPC, so that you get all the information, but at the same time you get the information already serialized, so you can use it freely and very easily.
Yeah.
But you don't lose on any information. That's the main takeaway for me.
Yeah. Okay. So I already gone ahead and done the request. Obviously, it's showing account balance as being 0. That's because this is a newly created wallet, and obviously we haven't transferred anything to it. We can, however, request a airdrop. Hopefully the faucet actually has coins. I haven't actually checked in a while, but a while ago it was pretty much dried out. Yeah. Okay, so I'm asking for 1 billion lampreds. This is pretty much one sol. So we have here the signature for the transaction where we asked for the airdrop. Now let me go on testnet here and see. So it's confirming. We could write some code to actually keep polling until the transaction is confirmed and stuff like that, but that's not the whole point of this. It's just more an overview of what you can do, how you should do this thing.
Actually, that part teaches you how to subscribe to the transaction and check whenever it's finished.
Yeah, I'm actually looking at it right now. Didn't remember that we had this part in here, but yeah. Okay, so we are going to do this properly. Obviously, that's the wrong one. Okay.
You're missing a using probably. Okay, that's yeah.
No. It was the wrong method. Yeah. Okay. So basically, once again, factory pattern. You want to get the RPC client. You get the RPC client. You want to get the WebSockets or the streaming RPC client. You use the get streaming client from the factory. And now what we're going to do here is I'm going to basically do the same thing, and I'm going to be subscribing to the signature. And basically, what this subscribe signature method does is it's going to subscribe um, to the confirmation or the finalization of that specific uh, signature. Basically, you can specify this by providing the commitment parameter. This is defaulting to finalized. I'm gonna go ahead and actually do this using confirm because it's faster. Not that you should do it, it's really context dependent. But what? Oh yeah, I was getting confused now. Yeah, okay, so when these
Go ahead and type. Well, I'll just say something quickly. Someone was asking if you could download the project after we finish. Actually, you can check it out right now. So on the repo, we have a solnet.examples project that is full of examples, and one of those examples is the this hello world that we're doing right now.
yeah, okay. So I was going to say, once this transaction is either finalized or actually confirmed, in this case, we're specifying the commitment, the confirmed commitment, you're going to get a notification of this. And in this notification, you're going to have access to possible errors that might have occurred in the transaction, or instruction errors which might have to deal with interaction with programs and things like that. Obviously, there are a couple of things easier, and I would need a whole other hour to actually go deeper into these because I had to actually parse these program-specific errors in .solnet.0 into a C# structure as well. So yeah, just to finishing up this key value for okay, so in doing this, we're going to be subscribed to this transaction signature, and the notification is only going to be fired once it actually confirms. So I'm going to do something here to confirm, obviously. Yeah. So that we can execute the whole code in a row and actually also have the transaction that we're going to craft afterwards be done in one single execution. Yeah, okay, so what we're going to do now is basically a small overview of what you can do with the transaction builder and the transaction and message classes.
Okay.
No,
There's a small note you're not changing the confirmed variable.
Yeah, I know. Yeah, so. the account already as well, so it's not an issue. I'm going to be talking mostly about this transaction builder. These has these methods. I'm going to be going over them a little bit more in depth. But I would also like to point out that you have this one, which exactly supposed to be like this. The message one and the transaction one. These were implemented specifically to allow interoperability with other SDKs, primarily the Web3.js one. It basically follows the same format, although when we're not interacting with any other SDK, we usually follow the route of using the transaction builder, which makes it way easier and much cleaner to actually implement things. Okay, so in order to craft a transaction and actually submit it to the cluster, we're going to need to request a recent block hash first. This block hash has about 30 seconds of time until it actually isn't valid anymore. So when you request a block hash, you have to be careful how long you're going to take until you actually use that block hash. I'm going to put our wallet as the fee payer. And then I'm going to add an instruction to the transaction, but I am going to call the memo program. And since this example was written, a lot of things have actually changed. We have also implemented the memo v2 program. We didn't break backwards compatibility, and I implemented it differently because the way we implemented the original memo program, it basically required the signer of the transaction to also sign the memo, basically. Now that's not the case anymore, and you can just do any kind of memo that you want. Yeah, so obviously, the same way that I was talking about the transaction and the message classes, which allow interoperability with the other SDKs, the transaction builder also has quality of life methods that allow for this. In this case, the compile message. I could compile this message right here, and I would only get the message. This is unsigned, and I could deserialize it using the message.deserialize. I could do it like this, and I would get the message. And this could be used to then do a transaction, basically just like the Web3.js one. And I could then populate the transaction following using the message and the signers, the signatures. In this case, what we're going to do is.
I think it's important to note that it's not just a question of interoperability with the other SDKs, because that's also the mechanism that allows you to use hardware wallets to sign a given transaction. Because the transaction builder is a nice quality of life, but it's very strict the way you use it if you want to sign directly. So with that mechanism, you can actually sign the transaction anywhere else you want and send it in somewhere else or back using Solnet.
Yeah, exactly. In this case, though, we are going to want to sign our transaction right away. As you can see, this build method actually has two overloads, with one of which takes a list of signers. This is used primarily for cases where you're dealing with the more complex programs or crafting way more complex transactions. And these transactions require to be signed by multiple accounts. What you do is you just pass a list of accounts where they are ordered in the way that they appear within the message and that they actually need to sign the message. I'm going to talk a bit more about that in a second, because that's actually a bit confusing sometimes. Yeah, so now I'm just going to this one. I'm just going to submit this transaction to the cluster. And I'm gonna run this.
This one should
Hopefully,
take a bit longer because you'll be waiting for the.
Yeah. Okay, so you can see here, obviously account balance is already 1 billion lamports because I had done the previous request and you're using the same account. We got the first transaction hash is 1 year, and we are probably subscribed right now.
Yeah, need to wait like 30 seconds, I think, for it to confirm that one.
No, it's already finalized. So what actually happened here? Yeah. It would be. I'm gonna run it again. No,
you didn't change.
What? Is here.
Not sure. Transaction is correct. Confirmed.
Okay, this one. Okay, whatever. I'm gonna do something. Keep it simple, so please. It's already. I'm wondering if this has been one of those cases where the RPC is actually not sending notifications as it should, because there has been a known issue where the RPC misses notifications.
Okay, it's you can send input on the console.
Yeah, I could have sent input anyway because I already advanced, but
yeah.
Okay, obviously there's something wrong here, but I'm pretty sure it's probably the RPC and not. That's fine. Once this confirms, you'll actually be able to see the contents of the transaction and see the memo. It actually.
Okay, yeah, SolScan doesn't support the memo v2 yet.
It does, but it doesn't convert from the encoding to the actual string. Yeah, okay. You can see here, transaction was signed by the account, which has a balance of 3.99 lamports because of the amount of time we had to run this, and then we have the memo program call here, which sends the memo that we wanted it to send. If I had done this using the first implementation of the memo program, I would have had to pass the account for the message to be signed because of the way we implemented it, and then you would have an extra parameter which was the signer for that message. Okay, so basically this is hello world. It's very simple. It doesn't go very much in depth, but other than this, we have a quite extensive collection of examples in the Solnet.examples project inside Solnet. And obviously we don't have that much more time to move forward with this, but I would like to give emphasis on the multi-sig examples that we have. This file here contains 1,000 lines of code, basically on how you not how you should do multi-sig operations, but a way to do them programmatically within C#. Obviously, this is very crude example, and I'm not using nonce accounts in most of these examples, though you definitely should because of the way multi-sigs happen and delays between signatures and stuff like that. And I'm not using the mechanisms which allow you to compile a message and populating them with, well, technically I am, but you would need to do this differently and not actually populating the message with the accounts that are actually going to sign the instructions and the transactions. But yeah, that's kind of it from my side. Should I still give a sneak peek into what I've been doing on Blazor side?
Yeah, just like 2 minutes. It should be.
Yeah. Okay. So it is here. What is it? It's here. Too many IDs open. So I'm just going to run the server right here. What you can see here is a Blazor WebAssembly application. I've been playing around with the NPM packages, which have the wallet adapters for the browser and obviously the React packages for UI as well. Obviously, I can't use those. I mean, I could use those, but it would be even more painful for me that I'm doing this and for whoever ended up using this because of the way it works and the way you would have a React and a Blazor WebAssembly application all in one. You don't want that. But yeah, I've been playing with this, and I can already. I have done this, but only Phantom is currently working. I can already connect to the wallet, and obviously I can already require certain signatures from the web application, because obviously there are some things that may still happen because of the way the JavaScript interoperability happens, and the fact that you're using C# to do these calls to the JS object references and stuff like that. This is still a lot of work to go until it's actually production ready for whoever wants to attempt doing Solana applications using Blazor. This is just a small example of the things that you actually can do using C#.NET and Solana. And we had some people telling us that we should give out some ideas of things that you could do using these tools. And I'm gonna put one of them out there, which is if you're a guy you're a guy or a girl, whatever, who likes trading, Solnet.0 is already in a state where it basically has all of the groundwork you need. Actually logging a lot. Solnet.0 is in a state where it basically has all of the groundwork that you would need for you to build a algorithmic trading framework, or just a framework for bots, for market makers, for whatever it is. And it is something that I would personally be doing it, but unfortunately there are just way too many things to do, and we can't obviously do all of them. So yeah, that's one of my ideas. If anyone is out there and you're interested in trading and on Zero and looking more in depth into things, this is something that I would encourage you to do. Obviously, Solnet.0 also has an examples library, which has quite a few of them. I remember there are two of them that go in depth into actually order placement, and then there's these two here, which are more niche and don't actually use the two primary classes in the rest of the project. But yeah, basically that's it. This has been, don't let the code coverage in this one fool you. This has been tested a lot over the course of the, I don't know, past 2 months or something. And it's very, very robust already. Yeah, you still want to show?
Yeah, I guess I can do a 1 minute sneak peek about what I've been working on.
Okay,
you stop sharing your screen.
Yeah.
Okay, let's go again. Share screen. There it is. Okay, so for the past few weeks, I've been working on the Anchor code generation for Solnet. I've had a few pains and some glory moments, and last night there was another pain moment, but I'm over it already. What I have right now is the code generation in the Solnet.Anchor project. I have a program which uses this library to actually receive input, and this input being the JSON. I didn't check the resolution. You guys can see things here a bit. Okay. Yeah, so there is this program I made quickly to just grab the JSON, parse it, and generate the code. And I already have some working examples. There's still a few a few minor issues with some edge cases that I still need to fix, but for now I can show, for example, it was yeah. This is the swap program, which is one of the anchor examples. So I have the project here, solnet.anchor.examples with two IDL files. There's the chat and the res. The res one is the one from the swap. I did name it properly. So I just ran the source gen program and generated the swap.cs. Okay, so this code might not be the prettiest because it was generated and in some cases the indentation doesn't work as a human would do it. However, all the objects are already created. There's even some quality of life niceties. For example, the account the accounts groups for each instruction, and beyond these, there's what you would expect. So there's all of the instructions, their construction is implemented here with the serialization of the data. This means that you only have to write your contract code in Rust using Anchor, and then you run this generated and you get the client code generation for free. Yeah, so here we have the static class program, just like we have in the remaining Solnet, where we have the transaction, the building of the transaction instruction, so you can build the transaction itself. You also have a client which abstracts most of these things if you just want to have a simple transaction building. So imagine you only want to create this transaction. Okay, so for more context, this is the rest. This is the swap program. So it has the instructions. Okay, so we have the swap instruction. The swap instruction. You just want to send this instruction. So basically, all you need to do is grab this client that is also generated and call the send swap with all the inputs as expected. And then there's maybe this bit that may be a bit scary. In order to have things a bit more flexible, there's this callback that you'll need to create to sign the transactions. This will be called with the payload and the public key of the account that needs to sign, and it needs to return the signature. If there's a transaction that needs multiple signatures, it will be called multiple times with the public key or different at each call. Okay, so this example is very simple. It doesn't really create any types, and I don't even think it creates accounts. Okay, I guess it doesn't even create accounts. So yeah, this is a very simple one. I have a more complex one here, which is the chat one. However, it's not yet 100% working. There's still a few things I still need to work out. For example, there's a PR that still needs to happen in the core of Solnet to read some stuff. Yeah, and there's this thing here that I need to fix about properties. But yeah, what's important here? What's important here is that all the types and accounts that are described in the ITL, they'll be generated for you with all the properties. And then you get for free the serialize and serializing methods. You will only have serializing methods on types, not on accounts, because you don't send an entire account on a an instruction, so you don't need to serialize those, but you need to deserialize those if you are retrieving one. Yeah, okay, so yeah, year types, you get the serialize as well. And okay, one small thing about the client, which is the base client that it's implemented in solnet.anchor. This base client has a couple of functions that allow you to retrieve or subscribe to any account that is described in a given IDL. So we have a get account and a subscribe account. Those are generic methods. They'll use they'll use reflection to retrieve the serialize method. This serialize method is automatically implemented, generated from the IDL and the type definition. So yeah, maybe this was too quick, but I think we're running out of time. And I just wanted to show you a sneak peek, but basically in the future, in the very near future, you just need to write the contracts and you get the free client with everything you need to write your application, be it like a Blazor WebAssembly, or in the future when Unity gets to move into Net 6, then, or any other type of application using .NET. Basically, you get the client and all these niceties for free, which means that you get to focus on the application and not on data serialization and deserialization. So yeah, I think that's the gist of it. I'm not sure if we have any questions right now.
We did have one question regarding the Citadel. I've already answered it in the chat. Other than that, I think we are going to wrap up. We've covered pretty much what we wanted to cover. Okay, so someone asked a question about where can we learn more about concepts like freezing authority. Yeah, you should. That's a difficult one actually. You should definitely take a look at the token program implementations, and if you know .NET, you can actually look at our own implementation of the program. You'll see that the freeze authority is actually optional when you do an initialize mint. Same thing with the yeah, the freeze authority is optional when you initialize a mint, which basically makes it a optional thing. Internally, it does logic when you don't pass the key, and when you don't pass the key, obviously there's no way to freeze any token account that is associated with that actual token mint. Obviously, this is different for NFTs, but I'm assuming that most of these latest launches actually don't have a freeze authority. Only some or maybe SMB actually added on their initial release. I'm not sure if that answers your question, but yeah, there's many documents, documentation, guides, whatever, so you can actually easily find out about it.
Yeah. Let me just reinforce to everyone watching that it's not too late to start building and in the great scheme of things, we're still very early. So you guys dive in, don't be afraid, ask questions, going to the Solent Discord. There's also several learning Discords out there. So feel free to join us and ask us questions. Also, go to our GitHub. I've shared it a couple of times in the chat. Go there. Feel free to participate, help us, ask questions. You're welcome, guys.
Sweet. Thank you so much, Tiago and Hugo. Really appreciate your presentation today, and looking forward to having you on next time.
Thank you.
Thank you for
All right.
having us.
Bye now.